Hey guys, I want to go ahead and talk about doing some of these inverse trig derivatives. Okay, and what I went ahead and did is I just kind of set up the problem ahead of time. So this is my original problem right here. Y is equal to cosine inverse of 4x. Well, in order to derive these formulas, what I had to go ahead and do is rewrite it. Okay, so this equation here became this guy right here. Okay, and if you notice, if we take cosine on both sides, because to get rid of this cosine inverse, we can take the cosine of y and cosine of this guy, cosine inverse, is going to simplify out. You're going to be left with 4x. Now this is something I understand, and if I make a right triangle, cosine of this angle is equal to 4x. That means cosine of this angle, so that means y is the angle, is equal, cosine is adjacent divided by hypotenuse. Adjacent divided by the hypotenuse. Okay, now all I need is this guy right here. This side right here, which I don't know. Well, how do I figure that out? Well, we use our Pythagorean theorem. A squared plus b squared equals c squared. You have your a, this is your b, this is your c. You solve it and you end up with b is equal to plus or minus 1 minus 4x squared. Okay, and I just left it like that unsimplified. Now, when we go ahead and take the derivative, we're going to go ahead and do it implicitly. The derivative of cosine is negative sine y, but because there's a y inside of it, we're going to do dy dx equals the derivative of 4x is 4. Well, when I solve for dy dx divided by negative sine of y, we get this relationship here. Well, what is the sine of y? Well, we go back to our triangle here, and we know that this guy is the square root of 1 minus the 1 minus 4x, the quantity 4x squared. So now sine is the opposite over the hypotenuse. So now it becomes clear. We go ahead and use this guy right here, and this becomes a derivative. Now we don't want to always be doing that, okay? But you can go ahead and do this for basically every inverse trig function, unless it gets really complicated. But I went ahead and wrote down the basic ones here. So sine inverse, if you notice, 1 minus x squared, that's exactly what we got here. The only difference is, if you notice, we have to use the chain rule, because what's inside of here? Well, it's a 4x. Well, we got to use the chain rule. The derivative of 4x is 4, and that's why you see here that 4 added up here on the top. Okay, but the general derivatives of these inverse functions, okay, sine inverse is 1 over the square root of 1 minus x squared. Cosine inverse is the same thing except with a negative. Okay, tangent inverse is nice because it's just 1 plus x squared. Cotangent, same thing except with that negative. All right, secant and cosecant are different. Secant is x times the square root of x squared minus 1. Cosecant is the negative right there that you see, x times square root of x squared minus 1. Now your professor sometimes might use x over a, and that's no problem because x over a, your a value, that's your 1. Okay, if you notice here, sine inverse of x over a, well, what happened here in the top? Well, here your a is just 1. Because if you think about it, we can do x over 1. Okay? So over here, same thing. The a replaces the 1. So a squared minus x squared. A squared plus x squared. And then x squared minus a squared. So let's go ahead and see if we can do a few of these. And do them real quickly here. Okay? Let me adjust this. Alright, so we know sine inverse of 3x squared. Well, I know the derivative, the formula, hopefully you can remember it. That's going to be the square root of, 1 over 1 minus whatever's inside here. Okay, well, what's inside? Well, 3x squared, and we're going to square that. But now, because I have something inside, I have a function inside, I have to take the derivative. Well, the derivative of 3x squared is 6x. And you can go ahead and simplify that, but that should be perfectly acceptable for your teachers. What about tangent inverse? Well, tangent inverse is what? 1 over 1 plus x squared. Well, whatever's inside here, that's 1 plus x squared, quantity squared, times, well, what's the derivative of the inside? Well, that would be 2x. Okay. Now we can go ahead and clean this guy up here. Let's go ahead and do that. So that would be 1 plus, you square the first one, plus you multiply these two times 2, so that becomes 2x squared. You square the last one, that becomes x to the 4th, and then you have your 2x on the top. And you can see, you can simplify this further, and I'll just let you guys go ahead and do that, but you should get 2x divided by, it looks like x to the 4th plus 2x squared plus 2. And that would be the final derivative, dy dx. Okay, I want to go ahead and do one that's u over a, and dy dx is equal to, we know it's arc sine, so I know it's 1 over something. Okay, and I know it's a square root of, well, we have, instead of 1, we have this a here, so it's a squared, which becomes 9. Well, what's that x squared? Well, the x squared becomes the 4, the 4x on the top. So it becomes this. Okay, times the derivative of, well, what's on the top? Well, it's the 4x times 4. Okay, guys? So hopefully that helps you guys out. Let me know if you have any more questions. I'll make some more videos.